Hi students, this is Saranya, Assistant Professor, Department of Mathematics, Dr. NGR Educational Research Institute. In this video, we are going to discuss about the chapter Automata. The one of the topic we have to see Turing machine. Turing. Now we are moving on the introduction. Turing machine. Turing machine automata or theory of competition. One of the subtopic is Turing machine we have to discuss. There is a much more powerful model of competition called in the Turing machine. The Turing machine is a shortly we have to take TM. Uh, it is the first proposed by the Alan Turing in 1936. Alan Turing. Alan Turing. He's a British mathematician. The Turing machine was invented by the Alan Turing in 1936. It is used to accept the recursive enumerable language. Turing machine is a fundamental concept in the theory of computation and playing the important role in the field of computer science. They were the first described by the mathematician and the computer scientist. The Alan Turing in 1936 was and provide the mathematical model of simple abstract computer. In the context of the automata theory and theory of competition, this machine used to study to the properties of algorithm and to determine what the problem cannot be solved in a computer. They provide the way to model to behavior of algorithm and to analyze their computational and then complex, which is the amount of the memory they require to solve the problem. Next. Turing machine's behavior is determined the finite state machine which consists consists a finite set of states, a transition function that define the action to be taken based on the current state, and the symbol being a read, a set of start accept state. Turing machine began in a start state and perform the action specified by the transition function until it reaches accept or reject state. If it is a reach accept state, now the competition considered as successful. If it reach reject state, now the competition is considered unsuccessful. Turing machine are an important tool for studying of limit of computations and for understanding the foundation of computer science. They provide a simple yet powerful model of computation that has been the wide used in research, has had a profound impact on our understanding of algorithm and competition. Turing machine is similar a finite automaton, but a Turing machine has an unlimited memory. You have in an unlimited, infinite number of symbol confined. Turing machine is a much more accurate model of the general purpose of computer. Turing machine can do everything that a real computer can do. Even a Turing machine cannot solve that certain problems. Such problems are beyond the theoretical limit of competition. Turing machine consists of a finite control, a tape, and a head that can be used for reading or writing on the tape. Turing machine is not simply one more class of automata. It may replaced later by a yet more powerful type. Any augmented Turing machine, multi-tape, random access machine are not stronger in terms of computing the power the basic Turing machine. Any augmented Turing machine can be converted into simple basic Turing machine. So the Turing machine seem to form a stable and maximal class of computational device. In terms of computational, they can perform Turing machine consists of a tape is infinite length, which is a read and write the operation is performed. Tape consists a infinite cell on which each cell either containing input cell or a special symbol called a blank. Input symbol A, B, 0, 1 and so on, and blank symbol any shape, B or capital B, B for blank, and some symbol like or star, anything you have to specify special symbol you can give. It is also consists a head pointer which point to cell the currently being a read, and it can move in both directions, left or right. So this is some example of the Turing machine infinite length, infinite state. So we have using some strings are there, 0, 1, and a blank symbol. This is a special symbol. This is special symbol. You have one header. That header is you have one finite controller. This is for your finite controller. So that's why I said Turing machine model uses infinite tape, unlimited memory. You have in unlimited memory. The tape head read or write. Once it is read, now again they have to do this process. It is a halt or not, you have to check it. Once it is accepted now, okay, symbol on symbols of the tape, the tape head can move left to right. Tape will be moving left to right. Turing machine competition. So what are the competition we have to using now? Competition. Read, write, start, leftmost position on the tape. Input string written the leftmost in square of the tape, rest is blank. The computational proceed according to the transition function. Given current state of machine, a current symbol being a read the machine. Transition is a new state. Q0 to Q1 is a new state. The write the symbol of the current positions, overwriting existing the symbol. The moves the tape head left or right. The computational end, if and when it enter, they either accept or rejected in the state. And we have to see in last. One kind of the problem we have to discuss, that problem will be accepted or not. Now coming to that, to what we have to see in here first now, what is Turing machine? Formal definition: Turing machine, design Turing machine, universal Turing machine, church Turing machine thesis. So first you know about that, what is Turing machine, formal definitions, and designing of Turing machine. That language, one language you have to given, with the help of the language we can frame the tape. uh, in your syllabus you have not doing the universal Turing machines and church Turing thesis, only have in a seeing a Turing machine. That is undesirable. What is Turing machine? Turing machine is a theoretical model and competition that can be implemented by the hardware or software. It is conceived an abstract machine that can be one of a finite number of states. Machine is only one state at a time. It can be changed from one state to another when triggered in some input. Turing machine is Turing machine is defined by the list of the states. It is the initial state, the input that triggered each transition, and the action that machine takes on each inputs. This is Turing machine. This is simply how to understand. uh, First you know about that finite state machine. After finite state machine is most powerful than the PDA. That both finite state machine and push-down automata is a very most powerful than Turing machines. The finite state machine for in a regular languages, push-down automata is a context-free languages. Turning machine is a enumerable, recursively enumerable, other turning in a recognizable in languages. Now